Hello everyone, this is Kamal, and in this video I'm gonna talk about assignment 4 for Comp 3132. First of all, we are importing the necessary libraries and dependencies for this assignment, and then here we are importing the data and split it into train images, train labels, test images, and test labels. And for this assignment, I'm using the Cipher 10 data, which is basically images of houses, cars, airplanes, buses, and so on, and they split it into 10 categories. Then this is just to test that I imported the data correctly. As you can see here, there is a small house for the first category, and then I'm just checking the shape of training images. We have 50,000 image, and they have the shape of 32 pixels width and the height 32 also, and also they have the RGB color values, which means they're classified as RGB. Then every image belongs to one category. Each image belongs to one category. That's why it's one here. And for the test images, we have 10,000 of them with the same values, same with heights and color values. And test labels also, each image belongs to one category. Then I'm dividing by 255 because I want to have a range between 0 and 1, and as we know, the color value for an RGB is between 0 and 255. So when I divide it by that number, I'll get a value between 0 and 1. Then in this part, I'm splitting the training dataset into two parts, the training data and the validation data. And also the test size is 20%, which means 80% is used for training and 20% used for validation. Then here I'm starting a sequential model, which means the layers are stacked one after another. The input shape, as you can see here, is 32 by 32 pixels, and they have three color channels. Then the layer of conv2D. These are convolutional layers. They apply filters to the images so they can detect features like edges and textures. Then I'm using the layers flattened, which basically convert the 2D feature into a 1D vector so it can be passed into dense layers. And here we have the fully connected layers. They take the extracted features and learn how to classify them. And lastly, we have the output layer, which is I'm using the activation softmax because it converts the output into probabilities. And here I configure the model for training. I use the Atom optimizer to update weights and the sparse categorical cranstropy as the loss function, which help for multi-class classification, and the accuracy at the evaluation metric. Then, after training the model, as you can see here, the accuracy started as 45% and the loss is 1.5. Then the accuracy validation is 53%. And as we go down, as you can see here, the accuracy is around 98%, but the validation accuracy is 58%, which is a clear sign of overfitting, and we can see it in this graph. The models keep training on the accuracy, which goes really high up to 98%, but the validation accuracy after like epoch 2, I would say, is start dropping down, which a clear sign of overfitting. And same thing here, the validation loss keep increasing and the training loss keep decreasing, which also a clear sign of overfitting. The test accuracy is 58%. It's not too bad, but the model is not learning what we expect them to do. And for the second model, I use max pooling and dropout. So for max pooling, it helps reduce the size of the feature map, which that helps to reduce the computation and prevent overfitting overall. And the dropout, this would normally turn off 50% of the neurons during training, which help prevents overfitting and improves the generalizing of the model. And then I added the data augmentation. This means that it creates modified version of the training images to improve the model's ability to generalize. And then I added the random flip horizontally. That helps the model to learn that the object can appear in different orientation. Then I added another random rotation, which is slightly like the it helps it shows that the image itself can be rotated to the left or the right, and also the layer a random zoom, which can be helps the model to see different scales of the image. All that helps the model generalize to better unseen data. And then I use the same compiler. And for the training result, as you can see here, the model started at the accuracy of 35% and the validation accuracy around 46%. And then as the model keep learning, it shows up an improvement of 64% and the validation accuracy is 61%, which is pretty good result. And as you can see here, the validation accuracy is pretty stable. It's fluctuating up and down, but it's a lot better than the first model. And the training accuracy is like about 64 point something percent. And for the training loss, it's also keep decreasing, and also the validation loss is decreased and a bit goes up and again goes down. So it's a pretty steady model and a lot better than the first one. And the test accuracy at the end it's 61%, which is pretty satisfying and is pretty good for this model. And that's it for assignment 4. Thanks for watching.